Hi students, I know that some of you are struggling with variance and standard deviation calculations, so I did an example in class and I wanted to repeat the example on video and share it again with the class as well as with the online class. I hope this is helpful. So the problem that we discussed was 6 people took a midterm exam in the psychology class, and these were their grades, and the question is quite simply calculate the variance and the standard deviation. Now, in the problem-solving process, the first thing that you need to do is to identify the problem so that you can write your formula. Okay, so I want you to think write my formula is my first step. Now, they've asked for variance and standard deviation. I go to my book, I look up the formula, and I find that there's 2 formulas. One is used if this is a sample. Notice the notation, S for standard deviation, little n for number of observations. The other formula is if the condition is that it's a population. Notice that we're using Greek letters. This is lowercase Greek s, sigma, capital N, meaning number of observations in the population, and this is mu, right, as opposed to x bar. Now, it says that there were 6 people that took the midterm, and it doesn't say 6 out of 10, so we have to assume this is everybody in this particular psychology class. Nice, small class. So we would say it's a population. So the first step in our problem-solving process is to write the correct formula, which would be this formula on the right. Now, I put a chart in this worksheet so that the students could choose as we did the in-class activity, but we've now decided that we are using this formula on the right. So the second step in the problem-solving process is to assign a value to each variable. I often say list your givens. So the problem-solving process, write your formula, list your givens. Okay, well, capital N, we need to know what that is. A mistake that students often make is when you list your givens, they will type out to me, one of the givens are that 6 people took the midterm. Well, that's not really what we mean. When we say list your givens, we mean write the variable N, and that is 6. So I'm going to come over here and say N equals 6. Well, now what does X equal? And it's important to understand that X does not equal any one value. Instead, X is going to, in turn, equal each and every one of these values. I'm going to list them all here, and then in a moment I'll show you how we organize those. Finally, I need to state what the mean is, and of course mu indicates the mean of the population. So I think the first thing that I might do is go to my calculator, or you know that the calculator that I use is Excel. Now these are the values, but Excel likes for things to be listed in a straight line like this. And of course, you know, you would sort and things like that. I might even label. I might even say these are my X values. Okay, so maybe you have this written down on a sheet of paper. I'll color code it just a little bit so that we can clearly see that X is the label. And then as long as I'm doing that, maybe I should follow the good practice of sorting my data. Why not? Okay, so I need the mean, and you know that means to sum up all the values and divide by the number of values, but Excel has a handy-dandy average function that I'm going to use. Now, when I did this example in class, a student brought to my attention that I was not following my own advice. And I'm probably going to have to go to part 2 and maybe even part 3 of this video, but if this is helpful, I hope that you will watch it through to its completion. What he was correcting me on is that I was carrying, see all these extra digits? And if your calculator simply displays 2 digits, you still have the other digits in the memory of your calculator or in the memory of Excel. Okay, so what you want to do is you want to clear out your calculator and you want to re-enter that value. Okay, so we're going to do that. So I've retyped my average. This is the population mean, okay? And instead of keeping all these decimals hanging out here, I'm going to clear out my calculator. I'm going to retype that in. So 78.17. These are now my givens. Wrote the formula, listed the givens, right? Calculated the average, made sure not to carry extra decimal places. Now what do? Well, typically what I would tell you to do, if you can see this at the bottom of the page here, is to rewrite the equation, but replace the variables with the values, right? Well, remember that our x value will take on several different values. And those values, I don't think I can copy and paste. 50, 65, 73, 50, 65, 73, right? 82, 99, 100. 82, 99, 100. Now what's the next step? Well, from this x value, I need to subtract the mean. Now, here's another mistake that students make. They try to take a shortcut because you say, well, surely I don't have to do this 1, 2, 3, 4, 5, 6 times. We had 6 observations. So you think maybe you could just add all these up and subtract the mean one time. It sounds so much more efficient. But it's not the procedure that the formula requires us to follow. So I'm going to, if you'll give me, I'm going to pause this if I can just a moment and put the values in here because this is simple subtraction and I know that you're capable of doing that. Okay, so I'm showing you my calculations here. Here's the x value minus the mean, and we said the mean was 78.17, and that would give us a negative number here. Now I'm rounding to 2 decimal places, and so that's what we have. Now remember, if you have just stored each one of these values into your calculator, then you may be carrying with you many extra decimal places. Now listen to what I'm saying. Just because you don't see, your calculator is not displaying those extra places after the decimal, doesn't mean that they're not there. They're in the memory of your calculator. So your calculator is set to display however many decimal places you told it to. And I believe the default is typically 2 decimal places. So just because the display is only visible, only 2 decimal places are visible, there could be many more places after the decimal that are invisible to you. So you need to clear that memory and retype those values into your calculator. Okay, obviously here, the next step, you can either type this into your calculator or do this in Excel, is to square, as we see here. So I'm going to go through the first one, negative 28.17, and of course as we square that, it's going to be a positive number, 793 point, now it's actually 0.5489, but I only want 2 decimal places, so I'm going to say 0.55, okay? Now again, I know you know how to square, so I'm going to pause the video and fill in these values. So I've squared each one of my values here. In other words, for each x, I've subtracted the mean, then I've taken that value and I've squared it. What does our formula tell us to do next? It tells us, now I'm going to go back up here to the formula, it tells us once we've taken x, subtracted the mean, and squared it, that we then need to sum. This capital Greek S, sigma, means to sum. This is little lowercase s. This is lowercase sigma. This is capital sigma. So I'm going to go down here, and so I'm summing. I've done this on my calculator, and I hope I've typed it in correctly. And I'm going to tell on myself a little bit because when I did this example in class, I had a young man who said, but wait a minute, I got a different answer because you're emphasizing to us that we need to round, but in the worksheet that I had done, I did not round. Well, you know, he was exactly correct, and it does cause a difference as you either round or don't round. This is the answer key that I had distributed to the class, and you see that I'm off 2/100ths, which may not seem like a big deal to you, but when you're using the Homework Manager Connect to solve this, it is going to check to a certain degree of accuracy, to within a certain deviation. And if we go beyond that deviation, then it will mark it wrong, and that's exactly what we want it to do. So I didn't follow the right practice when I first did that, and that student was exactly correct to call me on that. And so it was a good reminder to me, and I want to emphasize to you that we will get different answers if we are not clearing out our calculators and re-entering those values. All right, so what is this? 1918, it is x minus mu, each of those values squared, and then I've summed them all up. And the next thing that our formula tells us to do is to divide by n, and as you know, n is the total number of observations, and in our case that was 6. So I'm going to divide by 6, and I get 319. Now I'm rounding this out here, 81, because my calculator actually says 319.8066666666. And if your calculator, if you say, well, mine's not, it's just displaying 319.81, in the memory of your calculator, it retains much more than that. I'm sorry to keep beating that drum, but it is just a common source of error. Okay, so the very last thing that that we need to do, and really what I could ask you right here, I'm going to jump down to this, is throughout the course of this, are you calculating variance or standard deviation or both? Well, in order to get sigma, which is standard deviation, we must first calculate sigma squared, which is variance. So what this value is 319.81 squared, and it's test points squared. It's what the students earned on their exams squared. So this is variance, okay? In order to get standard deviation, we simply take this, which we've now resolved down to this part, and we need to take the square root. Well, maybe I'll go to Excel for that. You see I've been doing my calculations here. In Excel, we say square root 319 point, cleared it off my calculator. What was it, 80? 81? I'm going to double check. I apologize. Bear with me. 319.81. Okay, now, here again, I'm just going to emphasize this point one more time. This is what your calculator knows, even if it is showing you only that. Oops, right? So I'm going to type 17.88, and that is 17.88, my standard deviation. So did you calculate the variance or the standard deviation or both? Clearly you did both. What is the value of sigma squared? Well, sigma squared is variance. So what is the name of sigma squared? Variance. And this is sigma squared, right? It's the part of the formula before we took the square root. That being said, what is the value of sigma? Well, we calculated it as 17.88. What is the name of sigma? The name of sigma is standard deviation. And I hope this is helpful to you.